Now let us see about the Numpy program. So here, as we saw that we can create multiple dimensional array in Numpy using np.array. So np is nothing but Numpy is nothing but a package which we import using Numpy as np. So now let's create the one dimensional array and you can access it just like your list. But to create two dimensional array, you can do again, this is the syntax looks pretty similar like how you would see in the normal Python list. So you create your two dimensions and you initialize it with these list of elements. So this is my two dimensional array. Now there is the property called ndim, that is you can use to print the dimensions. Okay, to print the dimensions I can use ndim. So if you have a, let us say the array, and if you print and name it will be 1. But now I have this two-dimensional array for which the dimension would be 2. Okay, that is item size property which will print the byte size of each of these elements. Now these are integer elements, so that's why the item size is 4 bytes. As you know that integer occupy 4 bytes, or like if you have a float number, let's initialize the array with float as a data type. Now before I go with the print the current data type of this array, let's see is integer 32. Now I want to initialize the same array with different data type, then I need to use dtype argument. So here you can say that dtype is equal to np. Now you can say that float 64. Float 64 is one of the type. Now 64 means it occupies 8 bytes. So now when you print the item size instead of 4, it's going to be 8 because now each of these elements they are float numbers and they occupy 8 bytes. So if you print here, you can see the 1 point thing something. So this is now float. Okay, we will get more clear with this. And another important property that an array has is its size. Okay, so size is basically the size of your total number of element. So here you can see 1 2 3 4 5 6. So it has like total 6 elements. Then you have shape. So shape represents the information on dimensions, so short of like width and height. So here it has 3 rows, so 1 2 3. So 3 rows and 2 columns, so 12. Now already we covered the dtype argument, so let's just copy it from here and we can use it to dtype to initialize your array with specific data type. Now instead of float 64 you can also specify your type to be the complex number. So if you say complex, what is going to be? Is it going to create an array with complex numbers? Yes, sometimes you want to initialize your array with some placeholder numbers. Let's say you want to initialize your array with all zeros. If you want to do that, you will use np.zeros function and just mention your shape here. So shape means the information on your dimension. So this is creating an array of 3 by 4, that is 3 rows, 4 columns, 1 2 3 4, all initialized with zeros. You can do the same thing but with ones. So instead of zeros you will say ones and it will initialize all the element with the 1 number. Now sometimes you want to use a function similar to range. So you know that in Python there is a range function that we use for list. So what this function does, it's going to create a list of numbers from 0 to 4. So that was it did. Now a Numpy also has similar function, it is called a range. So if you do np here, if you do np.arrange or range basically 1 to 5, then this is going to create an array of 1 to 4 number. So pi is not included by default. That's how the even range function behaves. So this is very similar to Python's native range function. Now sometimes we want to do the same thing So let's say initialize array which from 1 to 4, but then you want to have like step of 2 numbers. So this means that you start at 1, then you take a step of 2. So 1 plus 2 is 3. 3 plus 2 is 5. But then this is your n. So this is your start and this is your n, and these are like number of steps. So once you reach 5, you will stop. So that's why it is 1 and 3 here. You can also use a linspace function. So now let's see the demo. That npl.linspace, to now here you will specify your start number and end number first, and then you will say start number is, let's say, 1 and the stop number is 5, and in between these two numbers I want to generate 10 numbers. Okay, so what this will do, it will generate 10 numbers between 15 which are linearly spaced. So you can see that you got this nice range of 15 and then these numbers are linearly spaced. Now if you do the same thing with, let's say, like 5, then they are spaced by number 1. You can do whatever you can do at even 20. This is useful if you want to create like a linear sequence of numbers. You can also reshape your arrays with reset function. For example, if you have this array and then the shape of this array is 3 by 2, it has 3 rows and 2 columns. And now let's say you want to reshape this to 2 by 3. So like reshape by 2 by 3 is nothing but 2 rows and 3 columns. So you can reshape it to any dimensions that you like, and the dimension should be compatible with the initial dimension. So you can even do a dot reshape. Let's see how. You have 6 rows and 1 columns. So you see 6 rows and 1 columns here. You can also use the Ravel function to flatten your array. So this will just flatten it, make it 1 dimension. So you have n dimension array when you call a dot. It will flatten, it may make it 1 dimension.